Okay, section 1.6. This is the first time that I'm trying notes from home, so instead of writing on the board, I'm using my notes to write, so hopefully you'll be able to read everything, and we'll see how it works. Okay, so 1.6 trig functions. Again, this should be a review from pre-calculus. The relationship between degrees and radians. Well, if we go all the way around the circle, that's 360 degrees, which is the same as 2 pi. So therefore, halfway around the circle, which is a 180-degree angle or a straight angle, is pi radians. You can just write down the second part, that pi equals 180 degrees. And if there's no degree sign, then it is always going to be radians. Trig functions for right triangles. So this is our basic definition of our 6 basic trig functions: sine, cosine, tangent, and then cosecant, which is 1 over sine, secant, which is 1 over cosine, cotangent, which is 1 over tangent, in terms of the opposite side, the hypotenuse side, and the adjacent side. And opposite side can also be written as the y value of the coordinate. Hypotenuse can also be written as the r, the radius, and the adjacent side can be written in terms of x. Okay, so if I have my angle, let's see how quickly I can do this. So if I have a point up here, right, this is my x comma y. Okay, and then if I have, this is a little bit slow. Okay, and then the distance between the origin and that point is going to be our r value. Okay, and then sine of that angle that's formed, right, this angle right here, will be the y value divided by the r value. So cosine of that angle will be x over r, and so on and so forth. So on your notes, you can just write down this column right here in terms of the x and the y and the r. You don't have to write down the rest of this. The next one are quotient identities. You should remember these, right? Tangent is sine over cosine, and cotangent is cosine over sine. And you can always check yourself, because if sine is y over r, and then cosine is x over r, then the r's will cancel. You get y over x, which is tangent. Okay. And our sum and difference identities. Okay. Hopefully you somewhat remember these from last year, at least the sine and the cosine, probably not the tangent one, but you will have to use these throughout the year. So sine of a plus b is sine of a cosine of b plus cosine of a sine of b. And then the minus one, sine of a minus b, is sine of a cosine of b minus cosine a sine b. So for the sine one, the sines, oh yeah, I did do that right. Then the sine and the cosine get mixed up. And then for the second one, but then my sines stay the same. And then for cosine, okay, my cosine and cosine stay together, my sine and sine stay together, and then the sines switch. So there's always one thing that stays the same and one thing that is the opposite. Okay. And then tangent is just a combination of those two. Okay. Tangent is the least important of those three. Next one are double angle identities. I know there's a lot of them, but the first one is absolutely the most important one. Sine of 2a equals 2 sine of a cosine of a. You have to know this in calculus. You're going to be using it because a lot of times it's going to be easier, say, to take the derivative of if you say find the derivative of sine of 2a, it'd be much easier to find the derivative of 2 sine of a cosine of a instead of sine of 2a. So therefore you're going to need to know the identity in order to start that question. Similarly down here, right, it's easier to take the derivative of something that's squared as opposed to a double angle like you have on the left-hand side. So those are all very, very good to know. Okay, and they may or may not be on the rest of your review game that we're playing tomorrow. Law of sines, hopefully you guys all remember because we started in geometry and we've been doing it ever since. Law of sines is sine of a over a equals sine of b over b equals sine of c over c, where capital A, B, and C are the angles, and lowercase a, b, and c are the sides that are opposite each of those angles. So side A is opposite angle A, and so on and so forth. Law of cosines, only wrote one of them because it is exactly the same you would just have to change what the letters A, B, and C are. So the moral of the story is whatever side this is has to match this angle here, and then these two sides are the same as these two sides here. So a third side squared equals first the sum of the squares of the first two sides minus 2 times those two sides multiplied together, cosine of the angle that's opposite that side. So you only have to write that one once. I didn't have to do that 3 times. And the last one, our most important ones, are Pythagorean identities. The most important of these ones is the first one, cosine squared theta plus sine squared theta equals 1. And then if I divide everything there by cosine squared, then I get the second one. If I take this first one and I divide everything by sine squared, I get the third one. So really they're all exactly the same thing. They're all based off of the sine squared theta plus cosine squared theta equals 1, which is our Pythagorean theorem, thus Pythagorean identity. Right, because this would be y over r, the whole thing squared, so that's y squared over r squared, plus this is x over r squared, so that's x squared over r squared. What does that equal? Or x squared plus y squared equals r squared, so you get r squared over r squared with a common denominator, which equals 1. Hopefully you followed that without me writing anything. Identify the ranges. So remember last year when we talked about, where can I draw? Here we go. When we had an angle, so say I have an angle that's out here. So say I say that the sine of this angle is 1/2. Okay, so that means that the y value is 1/2. Well, is that the only angle where the y value is 1/2? No, because if I go off this other way, so that these two angles are congruent, this one and this one, then both of those angles have a sine of 1/2. So we don't want to have two different answers for these, so therefore we restrict the ranges of our inverse functions. So we say that sine inverse, well, if it's a positive angle, right, so 1/2, I want my answer to be in the first quadrant and not in the second quadrant. If it's a negative angle, then it could be different color. Say it was negative 1/2, it could be here, and these will be congruent since they're all 1/2 or negative 1/2, so therefore they'll be the same angle. So it would be either here or here, and we only want the smallest possible one that has sine of that number. So therefore sine inverse, we restrict it to the first and the fourth quadrants. And of course sine can be 1 or negative 1. If it was positive 1, then it would be up here as pi over 2. If it's negative 1, then it would be down here as negative pi over 2. So our range for sine inverse is hard bracket negative pi over 2 to positive pi over 2. Okay. A little bit slow. Okay, for cosine inverse, it's a little bit different because it's positive and negative in different quadrants than sine inverse was. Whew, there we go. That was a lot of work. Let's get a blue marker. So glad you get to watch me change markers. Okay, so let's say that I had this original angle again. Okay, so the cosine is, I don't know, let's say 3/4, right, because I'm further over. So our cosine value is 3/4. And what other angle has that same cosine value of 3/4? Well, this one, right? If my x value is positive, then I have to go to the right, so that would be in the first or in the fourth quadrants. I don't want to have both of them, I just want to have one of those angles as my cosine inverse of 3/4. So therefore I'm going to restrict it to the first quadrant, not the fourth quadrant. And similarly, if it is a negative angle, so if I have cosine inverse of negative 3/4, I have my negative x value, so I went off to the left, either in the second quadrant or in the third quadrant. So I don't want that one, and I don't want that one. I just want the first two quadrants, and that'll be my answer. So it is, hard brackets again, 0 to pi. Thank goodness that one's easier to write. And it can be hard brackets because if it was 0, right here and here, okay, because cosine of 1 is 0, so since there's a value that I could get 0 out of it, then we can do 0, and we can also do pi. Okay, and the last one is tangent. Tangent is similar to sine, okay, because in the first quadrant, tan will be positive, and in the third quadrant, so we just want to get rid of this one, and then tan will be negative in the fourth quadrant and in the second quadrant. So if I look at the first and fourth quadrants, that'll give me the positive values in the first quadrant and the negative values in the fourth quadrant. So I'm going to go between negative pi over 2 and pi over 2, of course, the one that takes me longer to write. And in this case, I'm actually going to have soft brackets. Pi over 2. Oop. Because if you think about your tangent function, right, you have asymptotes at negative pi over 2 and pi over 2, right? Every odd pi over 2. So therefore, when you reflect it over the line y equals x, when you're taking the inverse, then those are going to become your horizontal asymptotes of y equals negative pi over 2 and y equals positive pi over 2, just like you had in the review game today. Okay. And also you can't take tan of pi over 2 because that would be 0, 1, and tan would be 1 over 0, which is undefined. And the same thing down here. That's 0, negative 1. Negative 1 over 0 is undefined, so we cannot include negative pi over 2 and positive pi over 2. Next question, evaluate the expression without using a calculator. Okay, sine inverse of negative 12 over 13. Oh, I guess I should probably put this in the correct quadrant, huh? First of all, this is the negative value. Well, I already started drawing my really pretty triangle. I don't know if I really want to delete it. So here's my theta, such that the angle opposite, right, so opposite, sine is opposite over hypotenuse, so I have opposite is negative 12. And the hypotenuse is always going to be positive, so that is 13. Opposite over hypotenuse. Okay. And then, so I want to figure out what is this other side, right? What's 13 squared minus 12 squared? That's 169 minus 144, which is 25, so that is 5. Those are 5, 12, 13 triangle. Okay. Evaluate what is tan of that. What is tan of theta now? Is tan of theta would be opposite over adjacent, so it would be negative 12 over 5. Negative 12 over 5. Okay, but why can't this be a negative number? Okay. It absolutely could. So let's make this a plus or minus. Okay, this doesn't tell us anything about what quadrant it's in, so therefore it could be in 2 different quadrants, right? Whereas sine negative, remember, all students take calculus. All of them are positive here. Sine is positive in the second quadrant. Tan is positive in the third quadrant. Cosine is positive in the fourth quadrant. And the rest are negative. So sine is negative here, oops, here and here. So therefore, my angle could have been in, well, my terminal side could have been in the third quadrant or in the fourth quadrant. Going all the way around here or all the way over here. Okay? And if it's over here, then it's going to be the negative 5, and then if it's over here, then it's going to be a positive 5. So without any additional information, we just have to leave it as both answers. It could be either one. Next question, evaluate the expression without a calculator. So here we don't know if x is positive or negative. So I'm just going to draw my generic triangle again. And make this angle theta right here. Tan inverse of 4x. That means that tan of that angle is 4x. So opposite over adjacent is 4x over 1. And then we solve for this side, Pythagorean theorem. 4x squared is 16x squared plus 1 squared, which is still 1. And then take the square root, and we get the hypotenuse. So now what is secant of theta? Secant is 1 over cosine. Cosine is adjacent over hypotenuse, so I get hypotenuse over adjacent. So we get square root of 16x squared plus 1. And of course we're going to do that without a calculator. Why would you do that with a calculator? Solve for x. Secant of x equals 3, and x is between 0 and 2 pi. Last example. So secant of x equals 3. First of all, this is 1 over cosine again. So cosine is 1/3. Let's write that. Cosine of x equals, I just took the reciprocal of both sides, 1/3. Okay, and just like before, we're going to have two different quadrants where cosine of x equals 1/3. Our x value, right, cosine is x value, is positive, then I'm going to the right, so I could either have gone up or down since then. So I'll make it look like this. Okay, because I only went over a little bit, because 1/3. And I want to solve for what angle this is here. And then I'm going to solve for this one all the way over here. Okay. So in order to do that, I need to do cosine inverse. So x equals cosine inverse of 1/3. Let me get out my handy dandy little calculator that's not quite as handy as the one at school. Let's make that go away. But we're doing easy calculations. So 1/3, and then I want to do cosine inverse, which I had no idea that you could do cosine inverse on these dinky little calculators here. I have mine in degrees because I want to show you how to change it into radians. So I got 70.529, we'll say. 70.529. 70.529. All right, now I'm starting to write like a little kid. Degrees. Okay. The problem is, let me just check this because I always copy numbers over incorrectly. Good. The problem is, this restricts us. Our x value should be between 0 and 2 pi, which is telling you you have to use radians. Okay. How do we change things from degrees to radians? Okay. Degrees to radians. All right, pi radians is the same thing as 180 degrees, so therefore I want to get rid of degrees, so I'm dividing by 180 and I multiply by pi. So let's say times pi equals divided by 180. I get 1.23 radians. It's about 1.23. Okay. And then, so that's my 1.23 radians. Well, that makes sense, right? This whole thing would be pi radians, so that'd be 3.14, whatever, 3 radians. And then a third of that, about 1, yeah, that looks about right. That's about a third of the way to 180 degrees. Okay. And my second one, well, I know that the whole circle is 2 pi radians, so I want to do 2 pi minus 1.23 because these two are congruent. Okay, so here I just have a positive 1.23. This direction I have 2 pi minus 1.23. So let's just say minus 2 times pi. equals that. And then I'm going to take the positive of it. And I get that 5.05 radians. 5.05. So those are my two answers. 1.23 radians and 5.05 radians. Okay. And those should add up to 2 pi radians, and I'll get 6.28. Yep, that sounds exactly right. That's it for your examples. Here's your homework. You only have 9 questions altogether. These are quick review, so hopefully it'll be easy, right? Quick review. And you just have 5 new exercises that should be very, very similar to what I just did on the notes. I hope this worked out well. We will see.